Okay, for this one I'm going to be pausing at times to do a bit of writing, so bear with me. So, prove that triangle OPQ is congruent to ORQ. First up, I guess I'll do the markings on the screen. So I've got my OT is radius, OP is a radius, OR is a radius. And I've also got to do, using the theorem of from the same point, the tangents are of the same length. So PQ and RQ are the same. Anyways, should be fairly straightforward. You should be able to see that OQ is going to be common to both triangles. You should be able to see that RQ and PQ are the same, and OP and OR are the same. So it's just going to be side, side, side. So I'll just pause to write all that in. And now we're back. I've just written that in. And yeah, that should be all that you'd need to do for that question. For the next question, prove that OQ is parallel to TR. So first up, given that OTR is theta, as it mentions in the question, this will also mean that ORT is going to be theta due to it being an isosceles triangle. And that also means that angle TOR at the top here is going to be, I'm just going to write it up here so it's a bit easier to see. That's going to be 180 minus 2 theta. So that's angle TOR. Okay, now from there, because we know that, we also know that, I'll do a slightly different color, we also know that this angle over here is going to be 180 minus 180 minus 2 theta. So that's going to be angle ROP is going to be equal to 180 degrees minus 180 take 2 theta, which hopefully will recognize 180 take 180 is 0, and the take 2 theta will just give us 2 theta. And therefore, each of those will be theta, because that line is bisected by the Q. Okay, because remember these sides are the same, all the sides are the same, these are identical triangles. So this big shape here, OPQR, has been cut in half. Alright, now that we've got that, we have to use the theorem that from a tangent, from the radius down to the tangent, that ends up being, hang on a sec, let's go to this one, that ends up being 90 degrees. So that's in diagram A, we can see that, from the radius down to the tangent line being 90 degrees. Therefore we know, as a result of that, that angle ORQ will be 90 degrees. Now if that one's 90, and this is theta, and we have to end up being 180, that means that angle OQR is going to be equal to 180 take 90 take theta, which is going to be 90 take theta, because obviously 180 take 90 equals 90. So we know that that angle in there is going to be 90 take theta, and now slightly different color, we also know that the angle in here is going to be 90 take theta, because we've already got a theta there due to our isosceles triangle, and our angle and our entire angle here has to be 90 because of going from the origin down the radius to the tangent. Therefore, we know that they are both the same angle. If these are the same angles, that means that these two lines are parallel. This line here and this line there are going to be parallel. So there's that one done. I'll just pause and do proper writing. And that's pretty much it. That's how I would have described largely what I've done. Anyways, we're going to move on to the next part, which is if TR equals TS, deduce that OTR is equilateral. So zoom in a little bit. We'll go a different color. Let's go purple. We're saying that TR, that line there, is going to be the same as TS. Determine that triangle OTR is equilateral, and I'll put 3 lines for now. And I guess the way that you could do that is, this will mean that TSR triangle is isosceles. And given that we know that ORS triangle in here is going to be 90 degrees, therefore we know that angle TRS is 90 take theta, which we've already got. And that also means that TSR is also going to be 90 take theta, because it's an isosceles. And therefore, because OSR as a triangle has to equal 180, that means that this angle at the top here would be 180 take 90 take 90 take theta. And actually, sorry, not that one. This angle up here would end up being 180 take the 90 degrees of here, take 90 take theta. And if you do that, then you're just going to get theta, which means all the 3 angles are the same, which means it's equilateral. But just to write out that last part, so for triangle OSR, it's going to be 180 degrees, take your 90 take theta. I always have that stuff in brackets, make sure I do it right. And take the 90 that we've got over here, and that will end up getting you to be just theta, because you've taken 2 lots of 90 away from 180, and you'll only have positive theta. And therefore, if you've got a triangle with 3 thetas, it must be an equilateral triangle with 3 even angles of 60 degrees. So that's all of question 4 done.